What's going on, everybody? So what is a signed and what is an unsigned integer? That is one of the questions from my latest PowerShell class, and we're going to answer that question today. In our coding world, there's various types of data types that represent numbers out there. Today, we're going to be looking at the integers. By definition, according to Webster's dictionary anyhow, an integer is any of the natural numbers, the negative of those numbers, or zero. Simply put, an integer is just a number that does not have any decimal values. Now, when you're deciding which type of integer to use, there are three questions that you need to be asking. Do you need negative or only positive numbers? How high or low does the value of your integer need to be to support your code? And are you concerned about memory limitations on the device that will be running your code? Before we dive in, I just want to give you kind of a reference of where these numbers are used. We're going to open up the documentation for the sim class sim_operating system. Now here in the sim_operating system class, we can see, if we zoom in here on the properties, we can see a variety of data types being used. I can see we have unsigned 64-bit integers. We have, let's see, an unsigned 32. We also have an unsigned 16-bit integer. Let's go ahead and extract out a couple of those members. And we can see here that we have a ulong, uint, and ushort. Just so you guys know that 64-bit integers are called long and 16-bit integers are also called short, so you may see them referenced either way. For your reference, I'm going to put links to the .NET Framework documentation on each one of the data types we're about to talk about. Also, if you want a copy of the source code, just go over to the Infotech Zones YouTube page, click on that community tab, and look for a posting on August 15th, 2024. We're going to start off looking at byte. Byte is an 8-bit integer. So let's take a look at the minimum and the maximum values for byte. And you can see byte goes from 0 to 255. But what if you need negative numbers? Well, that is where sbyte comes into play. So here with sbyte, you can see that the minimum value is negative 128 and the positive value is 127. Again, remember you need some bits in there to represent 0. That's why it doesn't go up to 128. But just like byte, it does have a total of 255 or 256 values if you include 0. So I'm going to run this code, and this code is going to give us a visualization of the bytes that are being used. So let's go ahead and run this. And let's scroll all the way up here to the top. What you're going to see in my column headers, and remember this code is available on the community tab of the Infotech Zone YouTube page. All right, so you guys can see I have over here, I have the bits. Now black means they're turned off and white means that they are turned on. So when they're all turned off, both sbytes, which is signed, and byte, which is unsigned, is 0. And as we continue to increment the least significant digit, or least significant byte, we can see that both numbers are counting up. But let's get to 127. Now this is where something different is going to happen. Right here you can see that we have the least 7 significant bits are all turned on, and one of them is turned off. Now right now both of these are saying 127. When we increment that least significant bit one more time, we can see that this one turns on, all the other ones are 0, and sbyte goes to a negative 128, whereas byte continues to count up. Now both of them are continuing to count up as we go down here. You can see that sbyte is counting up from negative 128, whereas byte continues to count where it left off. Now just for the fun of it, I'm going to run this little block of code, and this is going to display for us the minimum and maximum values for each one of these different integer types. So if you don't have any need for your value to go negative, then of course you're going to be using one of the unsigned integers. If you do need a negative value, then yeah, use one of the signed integers. Just understand that they can't count as high as an unsigned integer. So let's say I've got some type of a value, something I need to record. I'm recording it as an integer, and it's only going to have 50 possible values. Well, in that case, then I'm more than likely going to be choosing data type byte, simply because I do not need any negative numbers. And like I said, my value isn't going to go above 50. So byte is going to conserve memory, but still give me the number of values that I need. And just for the fun of it, I'm going to turn on this visualization of what it looks like when you're going through every possible combination of a 16-bit integer. Now remember, my channel is about the questions that I've received in the over 400 plus PowerShell, Azure, and Security Plus classes I've taught and that I'm still teaching. So make sure you hit that subscribe button and turn on your notifications. I'd also appreciate it if you give this video a thumbs up. And of course, I will see you all in the next episode. Take care.